That way, if we do answer some questions, other people it might help them later.
I don't have like a specific like problem, but if we could just go over like another example of implicit differentiation, I mean that's like the best way I know how to kind of do it is just by looking at example. So if there's
Right.
a way, just do one.
Sure. Yeah, I can make up a couple of examples. I'll try to kind of cover all the bases as far as the difficulty goes, because you know some of them were definitely more difficult than others. So let me share my notebook screen with you and we'll just do some. These are pretty easy to make up. So so let's look. You guys, so this is an example. You guys, we'll just start with finding dy dx, not at a certain point. So from like your part 1 homework, just finding dy dx and solving for it. So what if I've got 4x cubed plus 5y squared equals 10? And so your problem is just going to say find dy dx. It'll probably say by implicit differentiation, which is obviously the way we're going to go here. So what we want to do is you just make sure that you take the derivative of every single term in the problem, whether it's an x or a y. And if it is just a term with x's in it, remember you are just going to do that the normal way. So this would just be some power rule. We got 12x squared here. And if there's a y in it, you still do the normal technique. So we're still going to use the power rule, and I'm going to have 10y here. But because it was a y, we get that dy dx term. And then on the other side, I have a constant, so that's just going to equal 0. So technically, we have taken the derivative in this step right here. But we do want to solve for dy dx. So then from here, we can just subtract the other term. So in this case, subtract 12x squared. And we'll be at 10y dy dx equals negative 12x squared. And then to isolate that, remember that the 10 and the y and the dy dx are all just multiplied together. So you can just divide both sides by 10y. And you isolate your dy dx term. And it's just negative 12x squared over 10y. And then you could reduce that 12 and the 10 though. So let's call it negative 6x squared over 5y. And then as soon as that's isolated and your term is reduced as much as possible, then that would be your answer on that one. So remember, if it says this, but it doesn't give you a specific point to find it at, your answer is going to likely have x's and y's in it. And that's all right. Let's do one with a product rule. So let's do like 5x to the 4th, y to the 7th equals 14. Okay, so why is this one the product rule? Why is it different from the one we just did? Well, these two terms were added together and these are multiplied. So we have a product of two functions that we can't actually combine. So we call one of them u. So let's say that u equals 5x to the 4th, and then v can be the y to the 7th. So du is real straightforward, right? Because this is just an x term, so we're just going to get 20x cubed. But dv, we are going to do the power rule, just very straightforward like, but we're going to get 7y to the 6th, and then we have to add on the dy dx because this was a y term. So now let's put it together. So the derivative of this whole side over here is going to end up being u times the derivative of v, so I get 5x to the 4th times 7y to the 6th dy dx, plus v, which is just y to the 7th, times du, which is 20x cubed. So that's the derivative of that side. Now, on the other side, again, this is just constant, so we get equals 0. And then we start our isolating dy dx process. So let's subtract this term from both sides. And as I subtract it, I'm going to rewrite it a little bit because I'm going to put the 20, I'm saying the word 20 and my pen is writing it. I'm going to put the 20 in front, but I'm not going to change the term or anything. I'm just going to rewrite it to make it look a little better. I'm also going to multiply this 5 and the 7 together. So you guys, this is 35 x to the 4th, y to the 6th, dy dx. And over here, I'll have minus 20 y to the 7th x cubed. So I just changed the order a little bit. It's easier if you have your coefficients in the front. So from here, all I got to do is divide both sides by 35 x to the 4th, y to the 6th. And then I've isolated dy dx. So let's see what I can reduce here. The 20 over 35, now remember it still is negative, but I could take a 5 out of both of these and end up with a 4 over 7. Now what about the y's? If you take y to the 6th out of both, then the y's on the bottom are gone and you're just left with a y on top. And then a similar thing happens with the x's, except this time the x's on top will be gone and you'll just be left with an x on the bottom. So my fraction bar is way too long. There we go. So again, we isolated dy dx after we took the derivative, and then we reduced. And this one, you'll notice on your product rule ones, you might see a lot of reduction. And it's just because of the way the terms get laid out here. You have, you know, powers of x and y in both of your terms. They get put on top of each other. So, you know, there's a lot of cancellation happening. Let's see. Guys, what if I've got 3x squared minus e to the 3y equals 8? So you guys, I've got 3x squared. I know how to deal with that. I'm going to call that 6x. You guys, so let's talk exponential. I've got e to the 3y. So I know exponential terms, when I take the derivative, they come down exactly as is. I don't change anything. But because this exponent is not just an x, it's a 3y, I have to use the chain rule and I have to multiply by the derivative of 3y. So what's the derivative of 3y? Well, it's going to be 3 dy dx. So this is going to get a 3 dy dx. And on the other side, I'll have that 0. So let's subtract 6x from both sides. Make sure you keep this negative here. So I have, let's put this 3 in front too. So let's do negative 3 e to the 3y dy dx equals negative 6x. And then from here, as usual, we're going to divide by everything that's stuck to dy dx. No, hold on. I don't know why I wrote that. We're not dividing by dy dx. That's what we're dividing by. Okay, so dy dx is now alone. And over here, I've got negative 6x over negative 3 e to the 3y. So you guys, you can reduce a little on the negative 6 over negative 3. It's going to make that positive. And let's call it a 2 on top. It'll just be a 2 on top. So we'll have 2x over e to the 3y. So guys, now all of these techniques that we've used are the same techniques that you're going to use when you, for example, have to find dy dx at a point. remember that extra step is putting in the point. So for example, if I have, let's do a product rule with, let's do like 3x cubed times e to the, let's just do times e to the y equals, let's put some stuff over here. 5 minus y. Yeah, let's leave it like this. Okay, so I want to find dy dx. I have to think about this one for just a second. I want to make sure my all my terms don't go away. I think at 0, 1 will be fine. No. You guys, I want 1, 0. I've got that e term in there. It's going to make it life easier on us if y is 0. Okay, so let's find dy dx at 1, 0 in this problem. So I do have product rule over here. So I think the key on this, you guys, is make sure you don't take this point and sub it into the original. That's going to give you nothing of use, guys. It's going to really mess things up. So you have to take the derivative of everything first. Now, that dy dx that you find in this first step, it doesn't have to be isolated. You can then put in the point and then get your dy dx by itself. But you have to do that first step like you've been doing on all of these. So in our first step here with the product rule, I've got u equals 3x cubed. So du is going to be 9x squared. If v equals e to the y, then dv equals e to the y dy dx. So let's put that together as 3x cubed times e to the y dy dx plus v, which is e to the y times du, which is 9x squared, equals, what's on the other side? Well, this 5 turns into a 0. The minus y, what's the derivative of y? Well, that's exactly what dy dx means. It means derivative of y, right? Honestly, I could have made that 0, 1. It wouldn't even, no, it's better this way. Yeah, I like it. I like it, guys. So what's our next step? So this is not simplified in any way. I haven't combined any terms. I haven't tried to get dy dx on one side. And remember, that's fine. After you take that first step where you take the derivative of everything, this is where you put in your point at 1, 0. So x's are 1s, y's are 0. Let's see what happens. I'm going to have 3 times 1 cubed times e to the 0 dy dx plus e to the 0 times 9 times 1 squared equals negative dy dx. So let's simplify now. So first of all, 1 cubed is just 1. So really this is 3 times 1. What did I say e to the 0 was? Isn't that just 1? Because everything to the 0 is 1. So this is 3 times 1 times 1. So that is 3 dy dx. Plus, here's another e to the 0, which is just a 1, times 9 times 1. So that's just going to end up being 9, equals negative dy dx. Let's just call that a 9. I don't know why I wrote 1 times 9. I think we all see where that's coming from. Okay, so what do I do now? You guys, now is the time to get the dy dx's together and isolate them. So here's what I'm going to do first. I'm actually going to subtract the 9 first. I want to get the 9 on this side. So just doing it this one step at a time, I'll have 3 dy dx equals negative dy dx minus 9. Now let's get the dy dx from the right to the left. So you guys, if I have negative dy dx over here, all I have to do is add dy dx to both sides. So I have 3 dy dx's and I want to add 1, so that makes it 4 dy dx equals -9. Almost done. All I got to do now, divide both sides by 4. So you guys, it'd just be -9/4. You'll notice a lot of times these are fractions. They're not always, of course, but a lot of times they end up just being a random fraction. But do notice the difference in our answer here as opposed to the answers that we've gotten with the x's and y's in them. Why did I get just a single numbered answer here? Well, because after I found the derivative of all the terms, I put in the point. Remember, when you find the derivative at a point, what you're really finding is a slope. And that's why you just get a single number there. So guys, is there anything that you feel like in these examples I haven't covered or gone over? There absolutely could be things. I could be forgetting a lot of things. So if there is, you know, you can shout it out or stick it in chat. Let me know. Hopefully that has helped. I can put it back. I just, I unshared because I couldn't see my chat screen. But yes, so here's that again if you guys aren't done writing that. So you guys feel good now? Or maybe you felt good before, but you feel even better now?
Yeah, thank you.
Okay, cool. And you know where to find me if you've got questions. You know, just shoot me an email. You know, you can always be working on a problem in MATLAB and push the button that says email instructor, and then I can even see the exact problem you're working on instead of you having to try to use, you know, the keyboard to do all the math terms and stuff. That's the easiest way to go if you're working on a problem. It just sends it right to me. Okay. All right, guys. So let's cut out early then. So let's have a good Friday. That homework, you know, it's due on Sunday. So again, if you have problems while we're doing it or while you're doing it, just send me an email and I'll try to get back to you as soon as I can. So our next test is actually going to be at the end of next week, and the chapter is only chapter 12. So the last section, 12.5, is the last section that we're going to do. Chapter 12 is just these 5 sections. And so it's going to cover, you know, everything from 12.1, which was the first derivative test. Then we learned the second derivative in 12.2. Remember 12.3, it was kind of similar to 1 and 2, but we had those open and closed intervals. Then we have the 12.4 implicit that we just went over. 12.5 is actually related rates, and that'll be the last section. So basically what I'll do is I'll do 12.5 with you guys on Monday. I will post homework for that as well as a practice exam. Probably Tuesday or Wednesday, I'll have that posted. That way on Wednesday, we can have that day where you ask me questions. Like, I want you to see the practice exam so you can ask me questions about the practice exam. So that'll be what we do on Wednesday. And then Friday, we probably won't have a class because your test will be open. So basically the same setup as last time. You know, practice exam will be a quiz grade, so but you'll be able to do it as many times as you want. So yeah, same setup.
Okay, thank you.
No problem. All right, guys, so I'm gonna let you go, and I will, you know, see you on Monday if I don't talk to you before.